My name is Davi. I'm going to be reviewing a video by a channel called It's BS that supposedly debunks quantum mechanics. It's a bit of a longer video, so I've narrowed down two main topics to sort of review and debunk this person's debunking of quantum mechanics. Let's get started.
This video will explain how quantum mechanics is wrong. Anyone can understand what quantum mechanics is about, so here is a simplified explanation. First of all, it is a part of physics that describes how an atom works.
There's a lot more to it than just how an atom works.
There are only two particles that you need to know about. One is the photon, which is a particle of light. The other is an electron, which can be considered a particle that moves electricity.
There's more than just those two particles.
And finally, we have the electromagnetic field. Now you can see that I have classical and Einstein called out specifically in this description. The classical means that I'm not talking about a quantum electromagnetic field. Classical fields are represented by smooth, continuous flows of force, and quantum fields are represented by pixelated, discontinuous fields of force. And I mentioned Einstein here.
Okay, there's more than just the electromagnetic field. So right off the bat, this guy seems to have a bit of a basic understanding of quantum mechanics. And so let's move on to the first fallacy, the first topic this person tries to use against quantum mechanics and see how it's just false.
So let's focus on the photon light particle. This is absolutely the biggest problem with quantum mechanics. The simple question that you can ask any physicist is, what is the definition of a single photon particle? It sounds easy enough to answer that, but I'm telling you, there is no answer because of this.
Okay, so a photon is a discrete energy packet of an electromagnetic wave. So a single photon would be the minimum energy packet for an electromagnetic wave or wave packet.
Standard definition for a photon is based upon its energy, or E in this equation. And the photon's energy is proportional to its frequency, or F in this equation. And the kicker here is that this equation...
Okay, so the Planck equation describes the energy of a photon at a moment, not over a period of time. He's saying that this frequency term here means that it's an energy over 1 second, but that's not how the Planck equation works. The energy of a photon is instantaneous. The Planck equation gives the energy of a photon at a moment, not over a duration of time, not over 1 second.
Is a wave equation. It describes the behavior of waves and not a particle. So this is where wave-particle duality comes from. We're thinking about particles, but the math is using wave equations. Now let me show you how to illustrate this using a 3 Hertz frequency.
Okay, so we're talking about particles, but we're using wave math. Quantum mechanics explained this perfectly. Okay, so wave-particle duality, light is both a particle and a wave. What quantum mechanics tells us is that we can represent an electromagnetic wave using a wave function. This wave function is a superposition of states. Those states include a particle state and a wave state until we collapse the wave function by measuring that light, then in some way or manner, then we will collapse the wave function and it will converge into one state, a particle or a wave. It is both until you measure it, then it's one or the other. So wave particle duality is completely explained by quantum mechanics. The math works, the wave functions work, they successfully represent light in both its wave and particle state.
Example. Anyone can draw a visual representation of this wave equation. You can see we have 0 to 1 second represented on the x-axis. Instead of looking at this as a mathematical sinusoidal waveform, we can easily visualize it as waves of water. The x-axis would represent the surface of the water if it was calm and there were no waves. You can see the 3 wave peaks that happen within the 1 second period of time. So water is the medium that has been disturbed, and the effect of that disturbance are these waves. So now we have a frequency of 3 waves in 1 second of time. In other words, 3 Hertz. Now the 3 Hertz frequency needs to be multiplied by this letter h. So let's put an h by each one of these wave fronts. So each one of these h's represents the energy of each one of these waves. To follow on with our water analogy, I put them by the wave front because when we get hit by waves of water, we can feel the energy of the wave itself. Now, if you're to think of this as a particle of light or photon, you would somehow have to stretch this photon to be 1 second long in order to encapsulate the energy of this wave equation. So do you really think that photon particles are 1 second long?
Okay, I don't really understand what he's talking about. So how can a single photon have a frequency? Well, Quantum mechanics describes energy as being discrete rather than continuous, so the frequency of a wave is associated to that wave's energy. Light is an electromagnetic wave. This means that the energy of electromagnetic waves are discrete, and each discrete wave packet is a photon and helps make up that wave. And so, how can a single photon have a frequency? Well, it's the frequency of a photon is the frequency associated to that energy, to that wave, that energy level of that wave. So, he's trying to say that it doesn't make sense that a photon be a particle moving classically that will oscillate like a wave. And yeah, that's not what a photon is. It is a discrete energy packet of an electromagnetic wave. Okay. The next topic that I think is worth debunking is on the double slit experiment, which to try and debunk that is a bit ridiculous, if you ask me.
This is the absolute best experimental evidence against the existence of photons. So here's the basic setup for this experiment. We have a red laser pointer and a diffraction slide. The red laser pointer is a 650 nanometer wavelength. The diffraction slide was purchased from Amazon and is made by 3B Scientific. And here's a close-up of the diffraction slide. So now we can see the wave interference pattern that is created when the coherent light source, or the laser, is shot through this diffraction slide or through the double slit. You have the highest intensity light near the middle, and then you can see the bands of destructive interference where there is no light. So these waves interfered with each other and canceled each other out. And then bands of constructive interference where the light waves add to themselves. So light being a wave through a medium, which causes an interference pattern, explains this experiment.
Uh, Electromagnetic waves propagate through space, unless you want to get into quantum field theory, but I don't think that's what he's referring to when he says light propagating through the medium. I don't know what medium he's talking about.
Logically. It only gets weird when you add in Einstein's confusion around photon particles and the illogical concept of wave-particle duality for light. So let's go ahead and play along with the idea of the photon particle applied to this experiment. There are plenty of videos that already go into detail about the double slit experiment, but this Dr. Quantum animation seems to be a very popular one. And you can see right here, if you are shooting the idea of photon particles through the double slit, you would end up with two dots or two bands, as shown here. But when you do the experiment in real life, you don't see the two bands of these photon projectile particles. So then how do you explain photons making this interference pattern? It is because the photons are in a quantum state superposition. And while in that state, a single photon can pass through both slits at the same exact time and interfere with itself. This allows us to see the photon particles in an interference pattern like this, because it is in a quantum state superposition at this time. So if the photon's quantum state superposition were to decohere right now, then it would go back to the two blobs that we saw on the Dr. Quantum picture. As you can see, this is some of the quantum weirdness that people talk about. Sure, it's weird, but it's because it's wrong, not because this is how nature works. So from a particle perspective, you're looking at a fully cohered.
Okay, so in the double slit experiments, the photons are in the superposition before going through the slits. After the slits, the photons are still in a coherent superposition. If we try to measure which slit the photon went through, we collapse the wave function, causing a decoherence, and the photons then behave like a particle. I think that's what he's referring to here.
Quantum state superposition of photons. What I'm going to do now is add more noise to this environment to try to decohere this quantum state superposition of photons. Now, why would I do this? This is why quantum computing is not working, is based upon more.
Okay, so he's using a heat gun to try and decohere the interference pattern. I don't really see how a heat gun would cause a decoherence. You could think maybe the photons might interact with some of those heated up air molecules in the environment, but that's certainly not enough to decohere the system. And so he's saying that because we can't decohere the system, the quantum state superposition didn't exist in the first place, and it was always just a wave, which doesn't really make sense because this noise that he's adding, it's just not valid. He's also talking about how this is how quantum computers don't work. Quantum computers have been made. Right? There's the IBM series, there's Google, D-Wave. So I don't really understand where he's getting his facts from, but it just doesn't really seem to add up. That's the second topic I wanted to cover. It's a very long video, but in conclusion, I mean, this guy doesn't really understand what quantum mechanics is. He understands the double slit experiment, doesn't understands waves, understands classical physics. So it's a bit odd that he can't really try to wrap his head around quantum mechanics. I suppose maybe that's why he's trying to debunk it. He makes a lot of incorrect assumptions about quantum mechanics. Doesn't really understand the Planck equation. Doesn't understand how a wave function works. Quantum state superposition. Doesn't know that quantum computers are real and have been made. There's a lot. I mean, there's a lot of evidence for quantum mechanics, like experimental results, even like the Stern-Gerlach experiment, scanning tunneling microscopes, Bose-Einstein condensates. These are all things you can observe that are in line with the predictions made by quantum mechanics. Another fact that like results from quantum mechanics will often converge to the classical results when you take them in a classical limit, like the harmonic oscillator potential. So yeah, I don't really understand this guy's debunction. It's a bit bogus, if you ask me. And quantum mechanics is completely valid, in my opinion. Thanks for watching.